Welcome back, fellow programmers. And in this lecture, we are going to actually build our first neural network. So, this neural network will not be a wow factor neural network, if you will, that you could put on your phone. However, it is important in that it will show you the muscle behind Swift, where it does not need or is codependent on any type of model to build an actual neural network. So we are going to build a neural network. We're going to programmatically build the input, hidden, and output layers. And we're going to build a XOR neural network, train it to look at the inputs and give us the desired XOR, either high or low or on or off function or value at the end, at the output. So let's get started. We're going to go ahead. I have already imported the Apple Accelerate framework, as you can see here. So you can either follow along or download the actual playground that I've included for you and follow along that way, whichever way you want to do it. So the first thing we want to do is create the functions for our activation of our neural network. So let's do that now. And now we'll create a class for our neuron. Next, we will implement a class for the layers. Clean it up a little bit. And we can start our forward propagation for the prediction outputs. Next, we'll create a class for the network. So the next thing that we'll do is create a function for the training of the neural network. Now we'll create the validation syntax for our code and print out the results. And as you can see, the neural network is training. And it has completed its training. So all of these are the training layers, hidden layer, that we were able to show with Swift. These are the weights of the hidden layer and the output layer. And most importantly, we see the inputs that we coded in, and we expected, or expectations, or the truth that we wanted. And when the neural network was done learning, as you can see in the XOR output, that when off or 0 was expected, we have like 0.14, which is pretty much 99.96% accurate. Same with when we expected on or 1, we have 0.9. Same deal. And as you go down, you can see the same. When 0 was expected, it was always either 0.0. These are even more precise, 0.0. When 1 was expected, 0.93. This one was 0.97, etc. So that is your first neural network. We have a few more to implement, some that will be a lot more visual. In fact, the rest will be more visual. And we'll see you in the next lecture.